Alright, ladies and gentlemen, welcome back to Trig Equations, section 5.3, day 2. Okay, now we're going to be doing these things with a graphing calculator. Alright, so the solving equations basics, or at least the directions that we're going to work under here, we're going to round things to the nearest thousandth, so that's 3 decimal places for those of you decimal impaired. Alright. Okay, and then we're looking in the interval from 0 to 2 pi. Again, the bracket on the 0 means we're going to keep it if it's actually dead on 0, and the 2 pi with a parenthesis means we're not going to keep it if it's exactly 2 pi. Alright, so here's an example where some of that happens. Alright, so my equation is 0.2x times sine of x equals 0. Okay, so here's a graph that I've done, and in case it's not real obvious, basically what I went here is from negative pi to positive 3 pi. And basically, because my interval from 0 to 2 pi, I went just basically one further pi in either direction, so that I had plenty of room to work with so I can do all of my various calculator functions and not run into the edge of my graph and cause problems that way, because sometimes that happens. Alright, so anyway, looking at this, again, I've got one or two options. I can either just graph y equals what I have, and now because it's 0 on this side, just simply look for the x-intercepts. Or I could do a second equation, y equals 0, and graph that along with it and look for the intersections of the two graphs. Because this one was 0, I just left it alone and looked for x-intercepts. Okay, so again, from 0 to 2 pi, okay, that looks like I probably have something there. I have something right here for sure, and then again I've got something there, although since 2 pi is around 6.28, this one here is just a little bit to the right of 6, so it actually may fall just outside, so I'm going to have to kind of check that one just to be sure, but here we go. Alright, so using the various calculator features, again, depending on your calculator, it may or may not find this one as an x-intercept since the graph kind of hits it and bounces off. So you might need to do the second equation, the y equals 0, and look for an intersection, and if that doesn't work, you might have to resort to using the table feature. And using a table, you probably can find an x value of 0 that corresponds to a y value of 0. Basically, the moral of the story, 0 is actually a solution, and again, that's in the interval that we want, just on the edge of it for sure, but we're going to keep it. Okay, and then as our graph goes along, again, we use whatever calculator function. That should give us something 3.142, which clever people right there will see that that's actually just pi, rounded appropriately. And then, again, using our various calculator features of whatever this guy right here, does work out to be 6.28 something or other, and it actually is dead on 2 pi. And it does fall then, therefore, outside of the range of stuff that we're looking for. So basically, I just have my two solutions, this guy, and the 6 got thrown out. Alright, so anyway, there's that. Again, make sure you can do that on your calculator. It's very important. Just watching me do it doesn't do you that much good, so please try to play along yourself here. Alright, let's take a look at this other one here. It's got a couple little things to look out for, depending on how you handle it versus how your calculator handles it. So here we go. Alright, well, first thing first is you got the secant squared x minus cotangent x equals 2. Well, you can handle this one of two ways as far as typing in one equation or two equations in your calculator. You can basically pull the 2 to the left if you just want to type in 1, do secant squared x minus cotangent x minus 2 equals 0, and then you just graph y equals that thing, and then you look for x-intercepts again. For the sake of variety, what I chose to do here is graph y equals secant squared x minus cotangent x as one equation, and then graph y equals 2 as the other. And then what I'm going to do is look for intersections between the two. Okay, now clearly the blue one is the tricky guy here, and then the horizontal red one is y equals 2. Okay, now again, I left my window at negative pi to 3 pi here, but again, I'm really looking somewhere between 0 and 2 pi, which is going to fall right about where that vertical line goes through there. Okay, so again, I really don't care about the extreme edges of my graph, I just care about what's happening here in the middle. Okay, so again, I'm looking for the intersection, so if you find x-intercepts here, it's going to give you a bad answer, based on this graph at least. If you handle it the other way, of course, you're looking for x-intercepts, but, okay, like just visually, it looks like I've got one there, it looks like I've got one here, it looks like I got one here, and it looks like I got one here. And again, this one falls outside what I'm looking for, so I'm not going to worry about him. Same thing with this guy on the extreme left. Okay, so I've got potentially 4 solutions here, but if your calculator draws asymptotes, this is what you're going to see. If your calculator doesn't draw asymptotes, you're not going to see this one, and you're not going to see this one, because that's exactly what they are, asymptotes. Okay, so realistically, my 4 possibilities is drawn down to 2. So again, basically just be aware if your calculator draws any asymptotes, then asymptotes aren't actually points on the graph, they're just boundary lines that the calculator draws in depending on the calculator model and all that kind of stuff. So really, again, I'm just looking for two of these things. So using my appropriate calculator functions, hopefully you can get to 0.924, which again, then visually, that seems to make a little bit of sense. It looks pretty close to 1. And then over here, this guy looks pretty close to 4, and the calculator should give you 4.066 once you do all the appropriate rounding and all that kind of stuff. So again, just a few things to look out for, and again, depending on how you handle it, make sure you handle it appropriately depending on how you type things in. And again, make sure you interpret whether or not something's a valid solution or not based on whether it's an asymptote or not. That is very important. Alright, so I know you guys were so excited about having word problems that, I'd hate to deprive you of that. So here we go. So this one is actually one out of the book. The one in your assignment is, I'll admit, a little bit harder than this one, but let me get through this and get to the basics, and then, of course, ask in class for anything that trips you up in the other one. Okay, so again, we've got the function f of x equals sine of x over x and its graph. So basically, this is the graph the book gives you. Okay, so what's the domain of the function? Well, okay. Looks like everything here works, so just looking at that, whatever, but again, consider the equation, y equals sine of x over x. Well, sine itself doesn't have any bad values. Again, remember that's one just smooth continuous curve, so there's no domain values of issue, but since we're dividing by x, our domain, and I'll just for space reasons put it up here, our domain is basically all reals except x equals 0. Okay, so basically everything except 0 is your domain. Okay, moving on. B. Identify any symmetry and any asymptotes. Okay, well, just visually, hopefully this guy's got some pretty apparent symmetry. It's going through here, and it looks like it's symmetrical to the y-axis, and that's in fact what it is. So B, we've got y-axis symmetry. Okay, definitely not x-axis symmetry, and definitely not origin symmetry. Hopefully that's obvious enough. As far as asymptotes, we've got no asymptotes. Probably not real obvious, depending on how you're looking at this, but there are no asymptotes there. And asymptotes are nice boundary lines. They could be horizontal or vertical, but this guy really doesn't have either. Okay, C, describe your behavior as x approaches 0. Okay, again, because we do have a x equals 0 domain restriction, we do have something possibly funny going at 0, but again, just visually, you can see this guy. As I'm approaching 0 from both the left and the right-hand side, our graph, as I kind of trace it, is coming up here to a y value of 1 on both sides. So basically, that's what that's asking. The function as x approaches 0, you could either say y approaches 1 or f of x approaches 1. I'll just do it as f of x just because that's fancy. Alright, so the function approaches a value of 1 as x approaches 0. So that's all that is. Okay, how many solutions is the equation that have in the interval from -8 to 8? Okay, well, of course, that's the exact same expression as we graphed. So from -8 to 8, okay, so looking at the book's version of this, well, okay, this appears to be about -2 pi, and this appears to be about +2 pi right there, which again is 6 point something. Alright, 6.28, you know what I mean. Alright, but, okay, so it crosses here, so it looks like we've got 1, 2, 3, 4 solutions, but, just to be safe, okay, what I did here is I graphed it from -8 to +8. Again, if you're good, this probably isn't a necessary step, because if you notice, we cross at pi, and then we cross at 2 pi, so the next one should be around 3 pi, which is definitely more than 8. But anyway, just to verify that, graph this thing. Yeah, again, notice once we get to -8, we still haven't kind of curved back down to hit the x-axis again on either side. So basically, that means we've got 4 solutions. Alright, and then what are they? Well, basically, using our various calculator functions, we should eventually get solutions of x equals plus or minus 3.142, which again is just simply plus or minus pi. And then again, hopefully not too much of a shock as you find the other two, 6.283, which is just plus or minus 2 pi. So that's all that. Like I said, the one that I give in the assignment's got a couple of things here that make this a little trickier, but again, ask if you get stuck. Alright, well, there's the assignment. So moving right along. Pick 3, I mean exactly that. Out of those, there's not many more than 3, but pick your favorite 3 and go from there. 67 through 77 is the kind of wordy problems, and ignore all solutions on 67D. But anyway, so this is kind of more traditional word problem than the previous one I did, but here we go. The monthly sales in hundreds of units of skiing equipment at a sports store approximated by this wonderful Triggy sort of equation. Times t in months, 1 is January, and then sales exceed 7,500 units. Okay, now that's an important consideration, as is hundreds of units, and then this says 7,500. Okay, so you can see where I graph this here. Of course, the blue curvy thing is the kind of original function, is y equals. Okay, and then the 75, because again, number of units, 7,500 is obviously 7,500. So basically I graphed y equals 75 as my second equation. So I graph that and then graph y equals 75. Alright, so during the months when the sales exceed 7,500. So basically what I'm looking for is I want the blue line to be above the red line. Okay, and hopefully that kind of makes sense, where like the beginning of the year, your January-ish kind of parts, and then the December, November-ish kind of time of the year, you're probably going to sell more skiing equipment than like in these summer months that are kind of down here at the bottom. Okay, but okay, pretty obviously I think on January's going to be right in here. January is certainly above the 7,500. Although February, if I just kind of trace up here, it's pretty darn close, so that's maybe a little on the iffy side. Okay, again, tracking all the way across through the entire graph, I get here at 10, October, again, that's pretty darn close, so I do want to test that for sure. But then 11 and 12, you know, here and here for November and December, it's pretty clearly above. Alright, so really, I'm wondering about February, and I'm wondering about October as far as whether or not I include them. Okay, so we can do a few things. You can do the intersect feature and find out exactly what they are, but just one thing I want to highlight is you could kind of use your table. So by going to the table, okay, you can pull up a bunch of x and y values for this. And by doing so, okay, like again, we cared about February, so see 1 for January, and we see the 86.4-ish kind of decimal, and so that's clearly above the 75. February 2 ends up being actually 74.5-ish, and so close, but no cigar, so I'm actually not going to include February. Okay, scanning down, again, I'm going to skip 6, 7, blah, 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 all the way until I get to 10, because that's October, and again, that's the one that visually looked like that's pretty darn close. Because of a little bit of symmetry we have here in this graph, it works out to be 74.5 again, so again, life is not good for that guy. November ends up being the 86.4-ish kind of guy again, and then December very clearly way above at 90.8. So basically determine the months when the sales exceed 7,500. We've got January, we've got November, and then we've got December. Okay, I would kind of understand an argument that, well, since exactly at 10 it's only at 86.4, but later on in the month clearly it gets to be above 75. I think this is a graph that we can interpret is not as a continuous curve, is basically just a series of dots. So 3 there's a dot, 4 there's a dot, and so the dot, the actual whole number value, is the one that we really care about. So that's just a nice representation of it, but interpret the first of the month or the entire month as being whatever the actual whole number value is for that. If that makes sense, great. If that was a little bit confusing, I apologize. But anyway, anything that needs clarification, of course, ask in class, and I'll see you then.